Okay, welcome back to Get Ready for Calculus. This is Skill 2, Factor and Simplify Polynomials, and we're going to look at the rest of the page. We'll start on the top right. So we want to factor and simplify this. So this is a cubic polynomial, and we have 4 terms, so we want to see if we can factor this by grouping. Out of the first 2 here, I can take out a 2x squared, and that leaves an x minus 4. Now, out of the second group, there's actually nothing I can take out. And so what we want to do is we want to take out a 1, so to say, and what we see is that what remains, x minus 4, is the same thing that remained in the first group. And that's really important whenever you are factoring by grouping. Okay, now we want to divide everything by factoring the bottom. That's x plus 4 and x minus 4. And what we actually want to recognize is actually, never mind, nothing to recognize there. Okay, let's finish the grouping on top. So we take the front 2 pieces, 2x squared and the plus 1, and they become a factor together. And then the common factor is a factor, x minus 4, all over x plus 4 and x minus 4. And our x minus 4's cancel out. And so the factor and simplified would be 2x squared plus 1 on top and x plus 4 on bottom. All right, next one. So here we have a quadratic trinomial with an a number in front of x squared that's not 1. So we're going to factor 2x squared into some type of 2x and x. We want to multiply to 4 and add up to 9. So if we take that 2x times a 4, that gives us 8x, and then put a 1 here, that gives us 1x. 8x and 1x makes that 9x in the middle. And the bottom is already factored for us. We see we have some common factors that can cancel out, and so we have x plus 4 over 2. On this next one, we have a cubic trinomial, and we have an x that will factor out of everything on top. So I'll factor out an x, get x squared plus 5x plus 17. On the bottom, I can also factor out an x and get x minus 4. Now, we can see that these x's cancel out, and that's good. What we need to consider is, does this top quadratic trinomial factor? Are there 2 numbers that multiply to 17 that add up to 5? Because if there are, we want to factor it further and see if anything cancels out the x minus 4 on the bottom. And the truth is nothing else will factor out of that. So our final simplified answer is x squared plus 5x plus 17 over x minus 4. All right, and next one. A little bit weird, maybe a weird problem set up. We could factor an x out of that, or we could simply add it up and say we have 1/2 x over 3x. And then we can see we have x's cancel out, so we have 1/2 divided by 3, which is 1/2 times the reciprocal 1/3, which is 1/6. All right, next. It's still quadratically based, even though it's x to the 4th and x squared for our 2 terms. So we can still think of it as factoring a quadratic, 2 numbers that multiply to -4 that add up to 3. And our leading parts of those binomials will be x squareds instead of x's. So let's see, we can have a positive 4 and -1. And on the bottom, multiply up to 5 and add up to 6, 5 and 1. Now, at first glance, we might think, okay, nothing cancels out. It's already simplified. But I'm going to highlight this x squared minus 1. We see that's a difference of squares. That's a perfect square factoring. So we can change that to x plus 1, x minus 1. We can't do it with that x squared plus 4 because it only works on differences whenever you're subtracting, not whenever you're adding. And so now we see we have some x plus 1's cancel out. So we end up with x squared plus 4 times x minus 1 on top, all over x plus 5. And one more. All right, we want to factor the top. 2 numbers that multiply to 24 that add up to 10 would be plus 12 and minus 2. All of that is going to be over, well, it's already factored, x plus 12, x minus 2. Well, look what we have. We have everything cancels out, and that leaves us with 1. Okay, so there it is. That's skill number 2, factoring and simplifying polynomials. Let's look at an AI-generated math joke. Let's see. Tell me a math joke about, oh, let's see if it can come up with anything for polynomials. I feel like that's kind of a very specific ask. Let's see what ChatGPT can come up with. Why did the polynomial bring a ladder to the party? Because it wanted to find its highest degree. Okay, I guess I can get behind that. All right, there you go. Pythagorean.com if you need further resources. And good luck getting ready for calculus.